What's up, guys? So today I want to take you through my 3D printer setup and what's worked for me so far and the issues that I've had come up using the Bambu Lab H2D. So let's get it on. So I've been using this Bambu Lab H2D for the past couple months, and I gotta say it's an exceptional printer. It works right out of the box, no issues. Just get my 3D files, send it to the slicer, send it to the printer, and it prints virtually with no issues. So I want to go over the setup that I have and the stuff that I use for the printer, and it's a real simple setup. I mean, it's just a pair of cutters for the filament when you're first loading it in, or if you have to troubleshoot something in the AMS, and then a pair of needle nose pliers to usually use these to tear off the tree supports. Sometimes they leave a little piece of it on the print, so I'll use that to tear it off. Some build plate glue, and I like the Gorilla Glue, the super glue, and this Loctite flexible adhesive. Both of them work really well, and just keep a clean chip brush just in case for the clean off the build plate. And up here is all my measuring devices. I use my calipers a lot, the fillet gauge. If I'm trying to get the radius of a part, the weld fillet gauges work really well. X-Acto knife and just regular writing utensils, mechanical pencils, Sharpies, and steel rules, and calculator. And then I have my thread pitch gauge, so when I print out threads, I can check them and make sure that they are good. And this is actually one of my latest 3D prints, and I'm really happy with it. I didn't want to do the traditional monitor riser, and I wanted something that was going to maximize the space underneath the monitor, so I can clear up the desk, because all this stuff that was in these drawers was all over the desk and it was real messy. So I opted for this design, and the mount for the monitor, the stand for the monitor, goes through the body of the drawer base. So moving on to like designing things and designing your 3D print. So one thing I didn't think about when I was making this, because I was trying to maximize space, was that a power button is right in the middle under here. So I would have to flip up the monitor every time to turn it on. So the beautiful thing about 3D printing is you could 3D print solutions fairly quickly. So I decided to make like a little rocker, and this would essentially turn on the monitor or turn it off whenever I needed to, since these monitors are not compatible with regular remotes. So let me see if I can do it right now. So I just click that and it turns on. So moving on into my shop, I have a soldering iron, and this is a Hakko FX888DX, and it's a sweet little unit. It's all metal, feels good, and I started using this because I wanted a way to mechanically fasten the my 3D prints. So I didn't want to print plastic threads all the time, or use glue, or maybe some dowels, plastic dowels. And sometimes you just don't want to snap your prints together with dovetails and other ways like that. So I got these right here, these brass threaded inserts, and they come in M2 to M5. You can also get them larger, but this set comes from M2 to M5. And essentially what it is you take your soldering iron, screws on, and you pretty much want to make a 3D print with model it with a hole, and it'll have this end of the brass insert, which would be the minor diameter, and you just slip that into the hole, and then you put the soldering iron like that, and then you heat up the insert, and then you press it into the 3D print. So this has been really nice to have, so I can make my parts a little stronger. And these are the other inserts for the other sizes. And if you don't already have, you could just pick up, this is a 2,000 piece set with M2 to M5 with the nuts, washers, lock washers, all that good stuff. Two issues that I had so far since owning this printer was one day the screen mid-print decided to have no touch response, and the AMS2 Pro's internal hub decided to get clogged. And I reached out to Bambu Lab about both issues, and they just, I think within like a week and a half, they sent me a replacement screen and a new internal hub for the AMS. So I do have another video on my channel showing step by step how to take this the AMS2 Pro apart, get into the internal hub, take that apart, and pretty much clear the jam, put everything back together, showing that usually fixes the issue. Usually what it is just a small piece of filament, sometimes like a shaving of a filament can get caught up in there and cause this thing to throw a code on the screen, and it just won't fill. It won't let the filament go into the printer. It won't load it. I use Autodesk Fusion for all of my 3D print modeling, and it's a really good software. It's free for hobbyists and personal accounts, and it's a really good program to get tight tolerances, really good precision for your 3D print models. And you're also able to see the relationship of how your parts interact with the other 3D printed parts. So this thread arm attachment is this right here, and it's so neat to be able to prototype on the software, and in conjunction with the 3D printer, it's really good to bring your ideas to life. So there is a steep learning curve with Fusion. It took me about 2 months of practicing it every day, about an hour to 2 hours a day, and I would say I'm still a beginner, being I've been doing Fusion for the past, I want to say like 5-6 months, and there are tons of YouTube tutorials out there to be able to get a good grasp on where to begin and how to use the program. So I would say get into some type of 3D modeling software, whether it be Fusion, it be free CAD or Blender, and start learning how to model your own prints. If you have a 3D printer or you're looking to get into 3D printing, you could always start modeling before you get a 3D printer. This print is too big to print in one print, so I decided to cut it into 9 pieces. This is a 3 foot wide by 2 foot tall sign, and where these lines are over here going across the sign, that's where it's cut, and I've added these butterflies over here to snap these together. But another feature here that I ended up working out was using these clouds not as just protrusions on the sign itself. So I'll print the sign separately, and you'll see in a second in the bamboo slicer, they actually hold the sign together, which was pretty neat. I designed a smaller prototype, and it worked perfectly. It allowed me to take apart the sign and put the sign back together. So going into the slicer is what it looks like. So when you send it into the slicer, it'll come in as one sign, and then you have to split it into objects, and you'll be able to split up the sign into 9 pieces. So you see the clouds are over here. They're a completely separate piece from the main sign, and these will just snap in like over here. They'll snap in over here, and they'll hold the sign together. And then I also have the butterflies over here. So this is a pretty neat way to use Fusion and your slicer together to create bigger than normal prints. And over here, usually I have my settings set to 0.24 for my initial layer, height, and that has solved a lot of the issues I had with my first print layer, having like small tears or just looking kind of wonky. And for a print like this, I have ironing on, so the top surfaces of the sign and the letters look good. And I have it set to, the wall generator set to Arachne instead of Classic. So far I've printed 5 parts of this sign, and it came out looking really nice. So the strength, I have 5 walls, and I just use rectilinear for the top and bottom surface pattern, and then the sparse infill pattern I use Gyroid for the majority of my prints. I'll use like line or I've used the lightning. I didn't really care for that one so much, so I'll use like the line one if I need to print a quick prototype. That way it uses less filament and it's a little faster than Gyroid. But other than that, most of the time I just leave it on Gyroid. And other than that, that's pretty much, oh, and let me just show you one more thing actually. So if I go here to where the filament's at, and I click the 3 dots over here, I click edit, you get this screen over here, and this is where you can change your settings for during your print. So you could change a lot of the settings of your travel times, the bed layer, the bed temperatures, and the cooling, all that stuff. So the only thing I've really changed here was my textured PEI plate, the initial layer, and the other layers. You leave it at 60, and I've had no issues with bed adhesion. Occasionally you do get lifting, and that usually it happens like a little after the first layer has already been laid down. And what I found was, when I have this auxiliary part auxiliary fan, if I had that set too high, that'll cool the part so fast that it'll start shrinking, and it'll usually lift up on the left side of the print. So I changed this to 40, and sometimes I turn it down to 30. Some people turn it off and they have good success with that, but I usually leave it at 40 or 30, and like 95% of the prints. So that's pretty much my whole setup. If you guys have any questions or advice, drop it down in the comments. If you guys enjoyed the content, like, subscribe, and I'll catch you guys next time.